Hello, everyone. Today we will learn about multiplication of whole numbers. A times B, A and B is a factor of the product A times B. So A is a factor and B is a factor. Multiplication of whole numbers is a repeated addition. Now here's the definition. That A and B be any whole numbers, then the product of A and B, written A, B is defined. A times B equal B plus B plus B. And when A is not equal 0. So now here example. For example, A is 2, B is 3, right? So repeat the addition, how many B we repeat? We have a 1, 3, we have 2, 3 repeat. So therefore the answer will be equal 6, right? Repeat the addition, okay? Next, repeated addition. Here is some examples. We can do a multiplication of whole numbers. S toy company repeated addition. S toy company makes 350 toys a day. And how many toys are made in a 5-day work week? So therefore, we have to take a 550 times 5. So that will be the repeated addition. And why with the repeated addition, we have first day is 50, second 350, third day 350, and so on. So 5-day, right? So therefore, we have a 350, okay, times 5. Next, array model multiplication. Lisa is a part of biology research planted 5 rows of bean seeds, and each row contains 8 seeds. And how many seeds did she plant in her rectangular plot? So we have, because we have 5 rows, right? So each row is how many? 8 seeds. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. That's 1 row. And how many rows do we need? We need to have 5 rows. 5 rows. So I don't have another space. Get another one. So therefore, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. So therefore, we have 5 rows. Each one have 8 seeds. The total is 40. Okay. Next example. Rectangular area model for multiplication. So here is a problem. Jenny wants to order square tile to cover the floor of a 4 foot by 6 foot hallway. If the tiles are each 1 square foot, how many will she need to order? So we have 4 by how many? By 6. So 4 foot by 6. All right, so 6. So therefore, we take a 4 times 6, which is equal to 24. All right. Next example, multiplication tree model. Multiplication tree model. Domingo rolls a die and flip a coin. And how many outcomes are there? All right. How many outcomes are there? So roll a dice, flip a coin, roll a dice. So that will be 6. And then flip a coin is 2, because 2 sides. So therefore, it would be, outcome would be 12, okay? Next, question, product model or multiplication. So here Maya has 3 skirts and that she can mix or match with the 6 blouses. How many outfits does she have to wear? So we take a 3 times 6. Okay, how many different combinations? Would be 18. Okay. All right, so those examples for multiplication for problem. And then here is a theorem. Here's a theorem for property of a whole number. Closure property. If A and B are any whole numbers, and A times B is a unique whole number, right? So here is, for example, we have a 2, and then we can times 3, and then closure property, that means 2 times 3, which equals 6. 6 is unique number, right? Same as 2 times 5, 10 is a unique number, right? Okay. Next, commutative property. So if A and B are any 2 whole number, then A times B is equal B times A, right? So therefore, we take a 2 times 3, 3 times 2, right? This is equal 6. 3 times 2 is equal 6. So therefore, put an equal sign. So therefore, equal sign. So therefore, we can say A times B is equal B times A, okay? Next, associate property. If A, B, C are any 3 whole numbers, then A times B times C parentheses is equal B times A times B times parentheses times C, all right? So therefore, let's say we have A is 3, and then we have B is 2, n times 1, and we have 3 times 2 times 1. So therefore, we have 3 times 2 for this. We have 6 times 1 for this. So therefore, we have 6 is equal 6, right? So associate property, okay? Next. So multiplicative identity property of 1. The number 1 is a unique whole number for B times 1 is equal 1 times B. So equal B. Holds for whole number B. Okay. So you take any number, like a 5 times 1, which is equal 1 times 5, and then which is equal the number 5. Okay. And then you take any number times 0 times 0. So therefore got a 0. Okay. That's multiplication by 0 property. Okay. Now the next one will be the distributive property. All right. So now you take A times the parentheses B plus C, which is equal A times B plus parentheses A times C. All right. And you take A plus B parentheses times C, which is equal A times C plus B times C. Now distribute property is just like this. See, you want to distribute it like this. You take A times C plus B times C like this, right? So this is a distribute property. Okay. Now there's several different methods we can do the algorithm for whole number multiplication. Now using discrete property, using a lattice multiplication, and then Brace method, crisscross method, or Vector multiplication, German method, Russian peasant algorithm, and Egyptian method. So I will give you an example for each to explain for each method, okay? Now, discrete property, right? Discrete property. So a discrete property. Remember that a discrete property we have is what? Kind of a times b plus c, right? Now, which is equal, we want to do the discrete property, different color. So therefore, a times b, a times c, like this, right? So therefore, we got ab plus ac, like this, right? Now, how about if we have another discrete property, like this? We have, oh, first of all, I'm going to give you example. Give you examples. Let's say we have a is 2. Now b is, I will put this to you, this is true, okay? So when you take a discrete property here, you can see on this side, actually is, when we do the discrete property like this is a 2 times 3, this is 2 times 4, right? Now, I'm going to prove this to you, they are equal, okay? 2 times, actually, if you do the parentheses first, actually it's 2 times 7, is that right? Okay. Now, what about the other side? 2 times 3 is equal 6. 2 times 4 is equal to how many? Is equal 8. 2 times 7, how many? 14. 6 plus 8, how many? 14. Yes. So we find it out they are equal, right? So here is equal, right? So therefore, this is true, okay? Discrete property. Now, what about another problem like this? Let's say I have a plus b times c, okay? Now again, when I do the discrete property, so therefore this is equal what? Discrete property, the arrow sign that helps you to see AC is equal BC, right? Now, I want to give you another example for this. So let's say A is 3, B is 2, C is equal 1, right? So now A times C, A times C, which is 3 times 1. B times C, which is 2 times 1, right? So now, if we're moving down here, is 5 times 1. And this side is 3 plus 2 is equal 5. So therefore, 5 is equal 5. Yes, did you see it? Okay, discrete property, okay? Now here is an algorithm we can do for the discrete property is same. Like, let's say I have 11 times 12. 11 times 12 is equal how many? All right, so we can do discrete property for this, all right? We can make it 11 is what? Is 10 and 1. And 12, 10 and 2, right? So therefore, I'll do the discrete property. Now discrete property, make sure each one have chance to do the multiplication. Did you see? I have a line for this. Put on a different color. Put on a different color that helps discrete property. So now, what's the blue? 10 times, which is 10 times 10 plus 10 times 2, okay? Now plus the green one, which is 1 times 10 plus 1 times 2, right? So that would be 100. The total is 100 plus 20 plus 10 plus 2. So therefore, 100 plus 20 plus 10 plus 2, which is 132, right? 32. Okay. And then what we call this, we call it highlight this. This is called a partial product. We added out the total. This is called a partial product. I added out the total for partial product and finding out what's the total. Okay. So discrete property for this. All right. Next, lattice multiplication. Remember that we talk about lattice addition, and then we also can do lattice multiplication for this. Okay. All right. So let's say I want to do 11 times 12. 11 times 12, right? 11 times 12. Now, if you do it the traditional way, is like this, right? So we have 2 times 1, got a 2, 2 times 10. This one is 10, got a 22, right? 1, which is, this is 1, actually is not 1. We have 10 times 1, we got a 1, 10. We got 10 times 10, now we got 100. So answer we got 100, and then we can put on a 0 there, 32. So final answer is 132. So we're gonna prove this is gonna same answer for this. If we do the standard algorithm, okay? So I'm gonna use lattice, and then we can do this problem with lattice method, okay? So lattice method, let's get started with the lattice method for this. The lattice method, you take 11 times 12. Basically, you draw a box like this. And you draw a box like this, all right? Now, 11, where we put on 11? This is 11, right? So 11, we put on 1 and 1 there, right? Well, what about 12? When we put on the 12, we put on 1 and 2 there, okay? Let's get started for this, okay? Now, 1 times 1, how many? 1, so put on 0, 1. 1 times 2, how many? We'll put on the 0, 2. 1 times 1, how many? 1, so put on the 1 there. 2 times 1, how many? Which is equal to, put on the 0 and 2 there, okay? So here we have to find the final answer, okay? Here is the final answer, okay? Here's the final answer, okay? Now, I'm gonna erase this. Let's find out what's the final answer for this. All right, so this is the units, which is 2, okay? This is a tens, this is tens, right? So we take a 1 plus 0 plus 2, which is equal 3, right? We take a 0 plus 1 plus 0, how many? 1. So the answer will be equal 132. All right, that is method. Let me give you another problem to do, okay? Let's say we want to do 23 times 81 with the lattice method. So again, we put on the table like this, all right? 23, all right? 23, so therefore, put on the 2 and 3 right there. 81, put an A and 1 there, right? Then our answer will be right here, okay? Our answer will be right here. And then there'll be ones, tens, hundreds, thousands, okay? And that'll be our answer, okay? All right, so now I'm gonna erase these. Let's do it. Fill in the blank. All right, so now we're gonna fill in this. 3 times 8, how many? 24. 24, put on the 2 and 4 there. 2 times 8, how many? 16. So put on 1 and 6 there. 3 times 1, how many? 3. So put on 0, 3 there. 2 times 1, how many? 2. So put on the 0 and 2 there, okay? So the next, we're not add it up, okay? Add it up the total. So now, what's the ones? 3. So that'll be 3, put it down there. And next, tens, okay? Add it up the total like this. 4 plus 0 plus 2, how many? 6. Next, hundreds. 2 plus 6 plus 0, how many? That'll be 8. And 1,000, 1. So the answer will be 1,863. Okay? Lattice method. Let's do another problem. Let's say I want to do 37 times 59. Okay, 37 times 59. Again, I want to create a table like this. Lattice method. Lattice method. All right. Lattice method. 37 times 59. So 37 again, we put on the 3 and 7 there. And we put on 5 and 9 in there, right? And again, our final answer, ones will be there. 2 tens will be there. Hundreds will be there. 1,000 will be there, all right? So that'd be the answer, okay? And then we have to find out the partial product, add it out the total, okay? So now, add it up. 7 times 5, how many? 35. 7 times 9, how many? 63. 3 times 5, how many? 15. 1 and 5. 3 times 9, how many? 27. Okay. So now we want to add it up the total, right? This way, 3. Okay, 3, put it down there. 5 times 6 plus 7, how many? 5 plus 6 plus 7 would be 18. So 18, put on 8, remember 1 there, right? Now next, 1 plus 3 plus 5 plus 2, how many? Will be 11. So 11, put on a 1 there. Remember 1. 1 plus 1 is equal to. So the final answer is equal 2,183. Okay, so that is the latest method. Now the question is, can we do 3-digit times 3-digit? Yes, we still can do the 3-digit times 3-digit. And then this method, I think that the benefit of this method is very clear, with the place value. So if this method, if you using this method, all right, and if you do the like 3-digit times 3-digit or 4-digit times 4-digit, it's much easier than the standard algorithm. Okay, the standard algorithm sometimes take forever, but this one you take much less time than the standard algorithm. All right. Again, here we want to create a table. We make a table like this because it's 3-digit times 3-digit. All right, so 3, 2, 1. 321 put in there. 567, 567 like this, right? Okay, now fill in the box. 5 times 1, 5, 0, 5. 6 times 1 is equal 6. 7 times 1 is equal 7. 2 times 5, all right? 2 times 5 is 10. 2 times 6, 12. 2 times 7, 14. All right. Then next, 3 times 5, 15. 3 times 6, 18. 3 times 7, how many? 21, right? Okay, now we're gonna edit out the total here. This is a 7 for the ones. What about tens? 6 plus 0 plus 4, which is equal 10. So put on the 0, remember 1, okay? The next, 5 plus 1 plus 2 plus 1 plus 1 equal how many? Okay, it's 10, remember 1 there. 1 plus 0 plus 0 plus 1 plus 8 plus 2, how many? Which is equal 12. Put on the 2, remember 1 there. Then 1 plus 1 plus 5 plus 1, how many? Which is equal 8. All right. See, we added out the partial product like this. All right. Next one, put on 1 there. So therefore is equal 1A2007. That would be the final answer for this method. All right, next, we're gonna introduce Brace method. Brace method. So now Brace method, let's say I wanna do 17 times 35 for Brace method, okay? Now Brace method, we start from here. We start from here, right? We start from, let's say we take a 17 times 35. We start from 30, okay? So we do 30 times 10, then 30 times 7, okay? So 30 times 10. So therefore, we got how many? We got a 300, right? The next, we have a 30 times 7, right? 30 times 7, we have 210, right? Next, gonna use in different color. Next, we take a units times 10, and units times unit. So unit times 10. So we take the 5 times 10. Next 5 times 7, right? 5 times 10, which is 50. Unit times unit, 5 times 7, which is 35. Add it out the total, so 595, okay, 595. So that is the Bread's method. Now, Bread's method shows very clearly, place value. And then here, I want to use circle this. Partial product. The green here shows partial product. And then this is a final, not 595 is actually is what? Is a final product, okay? Let me do another problem for this. Bread's method. All right, so I wanted to do 11 times 12 with the Bread's method. Okay, so I will write it down 11 times 12 like this. All right, so Bread's method is what? We start with a 10. Take a 10 times 10. Take 10 times 1. So 10 times 10. So therefore, we got a 100. All right. And next, we take a 10 times 1, which is equal 10. Right. Next, I'm going to change different color. We take a 2 times 10, which is equal 20. And next, unit times unit, 2 times 1, which is equal to, add it out the total, that'll be 2, that'll be 332. Now, what is the partial product? If I ask you what's the partial product, this is a partial product. This is how we come with the partial product, okay? Bread's method. Next, we're gonna introduce crisscross method, right? Crisscross method, or method, or we can say Vedic multiplication. Multiplication. Okay. So now we have, we can say either is a crisscross method or Vedic multiplication. All right. So now, let's say we want to do 12 times 13 with a crisscross method. Now, crisscross method, in the beginning, you will create the dots like this. All right, so we have the final answer would be 3 digit. If I have a 2 digit times 2 digit, final answer will be 3 digit. Okay, 3 digit. All right, so I will create the dots like this. All right, so this method is from ancient Hindu method, and then people using the mental computation. So that would be a good way to help children to do the mental computation. Okay. So now the dots cross like this, and later you would understand what's the meaning for this. Okay. And you have a dots. So each dots here represent the 1 and 2. Here represent the 1 and 3. Here represent the 1 and 2. Here we represent 1 and 3. 1 and 2, 1 and 3. Now, eventually, you know, when do the mental computation, the dots will be in your mind, okay? So let's find out the answer for the first digit, all right? So therefore, you take a, actually, this means 2 times 3. 2 times 3, how many? Which is equal 6. The first digit is equal 6, right? The second digit, you have to do cross like this, cross like this. And what does this mean? This means, and because this represent 1, this represent 2, represent 1, and this is represent 3. So when we do cross, what's the cross mean? Cross, that means I take a 3 times 1 plus 2 times 1, right? So 3 times 1, which is equal 3, plus 2 times 1, which is equal 2. So final answer will be 5. So 5 put in here, right? Now the next hundreds, all right, is because we have dots like this for 100, all right? So therefore, and then you have, this means you times, okay? So take a 1 times 1, which is equal 1. So final answer will be 156, okay? And then this means what? When we take a 2 times 3, that means 2 times 3, which is equal 6, okay? Let's do another problem, okay? (11 times 12 with the crisscross method, okay? Now create the dots like this. And then the first one is like this. The second one is cross. And the third one, you times this, okay? Now, what's the dots here mean? This represent 1 and 1, 1 and 2, 1 and 1, 1 and 2, 1 and 1, 1 and 2, right? So now we take a 1 times 2, okay, 1 times 2, because this, right, 1 times 2, which is equal to 2, right? So the answer will be 2. The first digit is 2, okay? Now the second one is a cross, right? Cross. So therefore, it's a cross, right? And what's the cross mean? Cross, that means you take a 1 times 2, which is 2, right? Plus 1 times 1, right? So 2 plus 1, which is equal 3. So the second digit is equal 3 here, right? Now the final answer, final one, okay, erase this. It's, which is 1 times 1, right? 1 times 1. So therefore, we take, because this is, okay, we will do the multiplication like this order. So we take a 1, 1, 1, 2. So therefore, 1 times 1, which is equal to 1. All right, 1 times 1. Right? Okay, now let's do another problem. (21) times 15 equal how many? All right. So this time, I would like have you to, to do it without the dots, okay? So the dots is now is dots is in your mind, okay? So now we take a 1 times 5, so be 5, right? The next one is a cross, right? So we have to do cross. We have to do cross. The next one will be cross. So we have to cross, okay? Now the cross actually is what? 2 times 5, 2 times 5, one times 1, be 10 plus 1, which is 11. 11, right? So 11 actually put on 1 there, right? And remember what? Remember 1. Remember 1 there. And the next, you take 2 times 1, which is equal how many? Is equal 2. 2 plus 1, how many? Which is equal 3. So answer is 315, okay? Now, if you would still think, you want to do dots, that's fine. You still can, if you want to do dots. But eventually, in mental computation, you don't need the dots because the dots is in your mind, right? So if you want to still using the dots, we still can do it with the dots. All right. All right. So now crisscross method. Okay, we take a 1 times 5 and cross, and we get 2 times 1. That is, all right. 1 times 5, how many? 1 times 5 is equal 5. So put on 5 for this digit. Next is the cross, right? Cross. Now cross, we take because this is a cross like this, right? So we 2 times 5 plus 1 times 1, right? 2 times 5 is a 10 plus 1, which is equal 11, right? Now 11, what should we do? 11, we put on a 1 there, right? We only take the first digit. And now what about 10? Remember 1 there. Remember 1 there. So 11. And then next, because go to next place value. Now we will have a 2 times 1, which is equal, 2 times 1 is equal, how many? Is equal 2. Now take a 2 plus remember 1, which equals 3. Oh, so therefore we got 315. This method, right, is kind of lightning fast, and then help children to think about. But this method is good for quick learner, okay, quick learner. Let's do another one, crisscross method. 21 times 18. Now we have a dots like this. All right. Dots like this. Then we have we have units times unit, then cross, then tens times 10 like this, okay? Now what's the first digit is? 8 times 1, which is equal 8, right? Now the second one is equal to times 8 plus 1 times 1, which is 16 plus 1, which is equal 17. Now 17, you only put on 1 digit, which is 7, right? and then remember 1 there, right? So therefore, 2 times 1 is equal how many? 2 times 1 is equal how many? Is equal 2, and then 2 plus this remember 1, which is equal 3. So answer will be 378. Okay, this is crisscross method. All right. Now, let's do another method. I think so. We will leave another method for next time, right? I think so. We need to take a break for today, and thanks for watching. You have a great day. Thank you.